my name is Emma Chasen. I'm just going to quickly talk about how our design started off. When we first met with Nia, it was clear that she had a lot more motion in her wiggle than we originally thought, so we really wanted our design to incorporate that. So a lot of our brainstorming was about designs that could use her wiggle. And so we're going to quickly talk about patents.
I'm Corey Rucker. I looked into a lot of the patents that we did using the U.S. Patent Office search database and keywords. We actually found this patent, which was a device that allowed these two holes to be covered at the same time through springs and different interlocking mechanisms. So that actually sparked part of our design using to be able to cover more than one hole with just one press of a key. And I will pass it on to Logan now.
Okay, Logan, I looked at some benchmarking. We have two types of products here. We didn't know at first what exactly we want to do. We was torn between modifying a recorder or doing a full prosthetic. So we looked at both. The first is record design to play completely with just one hand. This was alright, but it was a very expensive option and didn't allow Nia to use a wiggle, which she wanted to do. The second was a really cheap option at $19. Just 6 separate pieces that you could allow to rotate the different holes. It had just a limited scale from C to A and required 6 fingers to play, which obviously she doesn't have. And then the next was some prosthetics. We had the Bionic 3, which is a very expensive carbon fiber hand that just came out. Incredibly complex microprocessors, but it does have auto grip strength and soft pads that you can allow to play the recorder. And last is just a DIY prosthetic voice controlled hand that we found online. Voice controlled, so which wouldn't be that great for music class, and it only does just simple commands that you, like hand gestures like waving or thumbs up or something like that. So definitely not a great option, but we used all this stuff towards our design to make it even better. I'll pass it off to Corinne to talk about human factors.
I had the human factors, so we were looking at ergonomics and the strength that she had. Ergonomics are basically just like the proper body position, so we wanted to make sure she didn't have too much repetition or the part wasn't like too hard for her to push down or too easy that she broke it. And we looked at safety features like choking hazards, making sure the parts were big enough that it wouldn't be considered a choking hazard, and how to clean them. And then next I'll go to Tyler.
I am Tyler. I'll be talking about the design. And our design is actually an attachment style, so no modification needs to be done to the recorder. And it's also an out-of-the-box attachment, so it's kind of like a plug-and-play. Once we've created it, it'll come out of the package and be attached right to the recorder without any extra modifications or anything. And it's also non-intrusive, which you can see on our next slide. It avoids the top 3 notes that Nia's already learned. And we're actually going to be covering the bottom 4 notes. And it's also not too cumbersome. As you can see, it's not an extremely large object on the recorder. It's also 4-key playable. So we're going to have all 4 keys can be played as a single note. And they can actually also be almost all 3 of the 4 keys have a secondary function, which allows them to play another note, so we can do any combination of the 4 keys. And then it's also a one-hand assembly, which is, like I was saying before, out of the box. She's going to be able to put it together herself without any help from anybody else or instructor. And on our next slide, we have the initial design, which was coming up with the patterning, which was, if we're going to cover 4 holes, we need to figure out how to make every combination possible. And you see we have notes, we call them 1 through 4 to make it simple. So we have 4 notes total, and then the top 3 notes also play a secondary note after a certain pressure is applied to the initial note. It's also the clamp is a skeleton design, which if we're going to make it out of metal or aluminum, then it'll be a lot lighter, that style, instead of having it a full revolution kind of thing. It's got a lot less weight to it that way. And it's also, we have the key drawing down bottom, which shows like the double action design, where she'd apply like a regular force, and it would play the single note, and then a larger force will play that note as well as a secondary note, which allows us to be a combination. And then we're gonna go on the calculations with Nick first.
Hey, I'm Nick Papiano, and I'm gonna briefly go over the calculations that we had to do for our design. First off, we calculated the maximum force that will be applied to the stainless steel pins that are used to support the levers on our device. We need to do this to ensure that the pin size that we chose would withstand the repeated force that Naya would have on the keys. And we also calculated the max bending deflection that the pin would undergo during use to make sure that it would not like overly deform and warp over time, because we want it to be able to last like a good amount of time. And we also calculated the torque that would be applied directly to the keys themselves, so we can make them strong enough and use that in figuring out which material to use for them. And we used like average forces that average children in Naya's age group would use, so it would be strong enough. I'll pass it over to Matt now to continue with some other calculations we did.
So the calculations that I started on and I'm still working on, because it's a fairly complex shape, as you can see from our design. But what I did was I took our design, the material that we're expecting to use, and tried to figure out, okay, well, what's the maximum force that this is going to ever withstand, and go from there to see. So what I did was I took one of our keys and I put a force right where the maximum moment, the maximum shear would be, and backtracked to find what the total force I could take was. And I'm currently working on a way to get Solid Edge to help us out with this as well, to do the full 3D setup. That's what I'm doing.
Dylan, I've been working on finding and researching for different materials that we want to use on our design. One of the calculations I did was finding the thermal expansion of our recorder and our bracket design. I wanted to see if we could put our device and the recorder into the dishwasher. It wasn't like a requirement, but it was asked of us to see if we could do it that way, so it would be easy for them to clean. So I found that a dishwasher is around 150 degrees Fahrenheit. And if we made our mounting brackets out of aluminum and the recorder being ABS, I found that the recorder would expand 3.5 times more than our bracket would, being aluminum. So if we wanted to make the whole thing be able to go right into the dishwasher, we want to keep in mind that the recorder is going to expand more than the bracket, so it might deform while in the dishwasher. So we just wanted to keep that in mind. Yep, that's all I had, and then I'll hand it back to Corey for our mock-ups.
Yep, I helped Emma with the mock-up. We actually did a mock-up with one of our key assemblies and just tested it to see one, how well it would fit around the recorder and the positioning of the tip to the actual holes of the recorder. That would be fast enough to rim.
So we contacted a few PEs. Bob and Dean both offered to help us to their availability and extent that they could. So far they've asked a few safety questions, and David Dvorak also volunteered to meet with us and discuss our design and our project. And I'll hand it up to him.
And so, to conclude, we'd just like to thank our sponsors and our supporters. Jessica Leeson is a physical therapist who helped us with the ergonomics and researching human factors. Jerome Boucher is an engineer at D&G Machine Products, and he's more than willing to help us laser cut our design. And Gary Walker is a metal specialist, also willing to help. And AJ Rutherford, a classmate, who actually helped take some time out of his schedule to teach us how to 3D print. Is there any questions?
Regarding the thermal expansion, you said the recorder was 3 times more than the aluminum, but what was the total actual change in length or size?
The change in length was only about 16 thousandths for the aluminum. I believe it was 4.8 thousandths for the recorder. So it was. We just wanted to make sure that we had a clearance fit in there, so that if it did expand, it wouldn't deform it. Good change.
We got to cut it short, right?
Thank you.